Okay, so in today's lesson, we're going to review operations on radicals, and it is organized in a Cornell note style strategy, which it was developed by the University of Cornell, in which it has a column that has space for questions, keywords, as you can see on the example here. What is a diagram um, about radicals? What is a diagram look like of radicals? Well, we can see the picture right here. You see that there's a radical symbol. There's a little number on the outside right there. 5 is the index. On the top, you write the radical. Inside, you write the radicand. And the radicand in this case is -32. The index is 5. And we don't always have to have the index written when there's no number written. That is basically think and just for you to remember that even though we do not write it in the index, for a square root is 2. Basically is, you're squaring it. What do radicals consist of? Radicals consist of two components, the index and the radicand. So if you see in the example right there, their number has basically in one of the examples, then there's a radical problem that is with a 9 being the radicand, and it has an index of 2, but it doesn't always have to have it. If it doesn't have any little tiny index number, then that's fine. Moving on. Which radicals can we add or subtract? Well, we can definitely add and subtract radicals that have the same index and the same radicand. That means the number inside the radical symbol has to be the same and the index has to be the same. And what do we subtract? We subtract the coefficients. As you can see in the example that I'm showing there, the coefficient is 11 and then -8. And basically, we're going to subtract 11 minus 8. There's 11 and then the minus and then 8 coefficient. It has 3 as the index. All of them have the index of 3. And it has 9 as the radicand. So this problem can be added or subtracted. In this case, the operation is calling for subtraction. Remember, if two radicals do not have the same index and same radicand, they cannot be added or subtracted. So look at the example above. It has the same index, all of them in the same radicand. And so then we subtract the coefficients, which are 11 minus 8, and the answer is 3. That's how we end up with the 3 outside the radical symbol and the 9 being the radicand.